Hi everyone, welcome to this tutorial on linked lists. Today we're going to look at how to delete a node from a linked list. If you've already tried to search for a data item in a node in a linked list and you get that, that's great. If you've looked at how to insert a node into a linked list, either at the end of the list or in the middle of the list, well done. Please continue. If you're not sure about those concepts yet, you should really make sure you review those before you move on to this tutorial. Okay? So make sure you know how to insert and how to search. Today's tutorial is going to be based on this scenario. We've got an array of nodes. Each node, the array has 5 nodes. The linked list starts at the root node, 0, and jumps to the node at index 1, which links to the node at index 3, which is the end of the list. Then we have the free pointer, which starts at index 2, jumps to index 4, and that node is the end of the free list. Okay, so hopefully you understand what I'm talking about. I've designed the node class with 2 attributes, data item and next p. I've constructed 5 nodes. These are the nodes that I've constructed. I have appended them into an array, and I've designed a couple of procedures to display some information in the lists. I've created a procedure called display list data, which loops through the linked list 16, 11, 15. That's what we should see when we run that code. Let's just check that. Display list data. Let's just run that. 16, 11, 15, that works. And I've also created a procedure which displays the free pointers. I figured out, I figured not really useful to display the free list data because it's just none. So why not display the pointers instead, 4 and then -1, okay? And just to help this procedure do what it's supposed to do, I'm going to tell it the value of the current free pointer, okay? So let's see if that works. Display free pointers, and the current free pointer is at index 2. So we'll run that, and it should be 4 and 1. Yes, it is. We're all good. Okay, so in today's tutorial, we're going to look at how to delete a node from a list and add it to the free list, right? So for example, if we're searching for a data item, for example 11, we're going to remove this node from the linked list, which is currently 0 to 1 to 3 end. We're going to remove it from there. So the new list will be 0 to 3. That's the new list. And the new free list will be 2 to 4 to 1. Okay, that will be the new free list. So let's look at how to do this in Python. We've got about 10 minutes of video time. Let's see if we can get it done within those 10 minutes. So I'm going to define a procedure called delete node. And I'm going to give it as parameters an item. And I'm also going to tell it the current value of the free pointer, because later we will be processing the free list. The data that we're going to be messing around with is our nodes array, which is a global variable. So I'm just going to tell my procedure that that's what we're going to be playing with. Let's start by removing or deleting the node with the search item, which is this item here. This is the thing we're looking for that we're going to remove. So we'll set up a search pointer and we'll assign it to the value of the root index. And then we're going to say while nodes search pointer dot data item isn't the same as the item that we're looking for, and we haven't yet reached the end of the list, we're going to do two things. We're going to store the value of the current node. I'm going to call it current node, which is just the current value of search pointer. So remember, when we start at node 0, current node will be 0. So we've got the 0. And search pointer will be updated. Search pointer dot next p. So let's say we're trying to remove the item 11, this node here, from the list. C node will be 0, search pointer becomes 1, while node search pointer, so nodes 1 dot data item doesn't equal the item that we're looking for. Well, that's 11. It does, so the loop stops. When the loop stops, C node is 0 and search pointer is 1. We have these two values stored. Brilliant. That's exactly what we need. We now need to determine which of these two conditions made us leave this while loop. So what we're going to say is if search pointer made it all the way to -1, we're just going to print item not in list. Right? If the search pointer gets all the way to the end of the list and we didn't find the thing that we were looking for, it means it's not in the list. Else, we're going to do some stuff. We're going to change index zeros. Remember, we've got the values 0 and 1. C node is 0 and search pointer is 1. So we're going to change this to be this one's this, if you see what I mean. Does that make sense? Let me write it down in Python and hopefully that will make sense. Nodes, which variable was storing the 0? It was C node, wasn't it? So nodes C node dot next pointer will be assigned nodes. Which variable was storing the 1? Remember, we captured the 0 and the 1, or search pointer captured the 1. Bingo! We've done it. We've done it! I think. Node 0 next p is assigned nodes 1 next p, so this becomes 3. Bing! We've removed this from the list. Let's see if that works. In my computer program, let's just get our computer program down here a little bit. Let's call that method delete node, and the item is 11 and the free pointer is 2. We haven't done any free pointer processing yet, but we will in a minute. And then we'll display the list data. Hopefully we'll see 16 and then 15. There's no longer any 11. 16 and 15. Brilliant, it worked. Okay, so that seems to work. Now then, now that we've removed the node from the main list, let's add the removed node to the free list. Okay? So what we need to do is find the end of the free list. We need to get to this point here. Okay, so we're going to do another search, but we're going to be using the value fp as the start of the search this time. We're not going to start at 0, we're going to start at 2. And I have that value as a parameter. Okay? So I'm going to say free search is equal to this fp. And while free search doesn't equal -1, nodes free search dot next p. Sorry, that's not true, is it? What am I doing here? We're updating free search. Free search equals nodes free search dot next p. Okay. So finally, free search is going to have a value of -1, but we also need that value 4 because this is the node that we're going to be updating. Okay, so what we're going to have to do is something similar to this. I'm going to use it again. I'm going to say f node equals free search. So f node will be 2 and free search becomes 4. Bring. F node becomes 4 and free search becomes -1 and we're out of the loop. But we grabbed that value. We need it because this is what we're going to do with it. Nodes f node, which is 4, dot next p will be assigned, well, it has to be 1, doesn't it? It's going back to 1. Can you remember which of these variables we used before already has stored 1? Was it cnode or was it search pointer? It was search pointer, wasn't it? So that's brilliant. That will become 1, and we need this one. This is the end of the free list now. So we change this to -1. We could change the data item to none as well, just so it's consistent with all the other nodes in the free list. So nodes 1, so that was at search pointer, right? Nodes search pointer dot data item equals none, and nodes search pointer dot next p will be assigned -1 because that's the end of the new free list. Okay, so let's delete a node, let's display the list data, and let's also display the free pointers. And we're going to, before we display the free pointers, we've deleted a node, haven't we? So that's fine. Display free pointers, and the free pointer is still 2. So let's see if that works. Oh, invalid syntax, come on. Hopefully that's the only error because we are running out of time. So 4, so it starts at 4. Then it goes to 1, so that's changed to 1. That has become 1. Brilliant. And then this is -1. It worked!